Hi, this is Mr. Dittmer, Algebra 2 teacher at American Indian Public Charter High School in Oakland. This is my third video on section 14.6 from our book. The objective is evaluate trigonometric functions of the sum or difference of two angles. This is my third video on this section, but the first two videos were really one video. There was kind of a technical mistake that made me split it into two. I'm gonna try to go fast. You can pause me as often as you need to. These are the sum and difference formulas, and we talked about them last videos, and we showed how to. I think in the last video we looked at how to find like cosine 75, and we showed how like there's only certain angles that we know how to solve without calculators. To solve trigonometric functions for. Like we know cosine 30, cosine 45, cosine 60, and sine and tangent for those three special angles. They're all on this drawing right here, 30, 45, 60, cosine, sine, cosine, sine. But how do we do cosine 75? That's not on here. It's not a special angle. Well, we can divide it up into 45 plus 30, and then we've got something. So that's the sum and difference angle formulas helping us. It's a complicated formula, and you have to work it out, and it gets you something that you put in simplest radical form. I think the answer to cosine 75 was root 2 plus root 6 over 4 was our final answer, if I remember correctly. So we've got to do a lot of algebra to work our way through that formula. So a little bit more tricky problems that I want to cover this video. The first one is find sine u minus v, given that sine u is negative 3/5 with pi less than u less than 3 pi over 2, and cosine v is 12/13 with 0 is less than v is less than pi over 2. So basically, aside from using these, this problem is more difficult because instead of just using these formulas, instead of giving us u and v, or us plugging in u and v like 40 and 35, 45 and 30, they're not giving us u and v. They're giving us sine of u and cosine of v. That means we have to figure out what sine of v is and what cosine of u is, because all four of those values come into these formulas: sine u, cosine v, cosine u, sine v. So how are we going to find out what the missing ones? Well, if you're looking around the screen, you can always see that if you've got sine u and you need sine v, there's an important identity that, and if you remember one identity from all of trigonometry, remember this one. It's very important. Sine squared of an angle plus cosine squared of that same angle equals 1. What that means is that on say a trig table, on any line, the sine squared plus the cosine squared will equal 1. These numbers themselves, if you add them, don't equal 1, but when you square them, the sum of the squares will equal 1 on any line all of the time. Sine 62 squared plus cos 62 squared equals 1. Sine 76 squared plus cos 76 squared. You get the idea. And so, using that, if I know they gave me what sine u is negative 3/5. So I plug in, I plug this into, I plug what they give me into this identity, and so sine u squared plus cos u squared equals 1. So negative 3/5 squared plus, I'm just going to shorthand this and call it b squared equals 1. This is 9/25. How many 25ths is this? 25 25ths. So I'm going to subtract 9/25 from both sides, and that cancels this out. And so I got b squared equals 25 25ths minus 9 25ths is 16 25ths. So I subtracted the 9 25ths from both sides. I didn't write it, but I did. And so then I square root both sides, and b equals 4/5. But this other information they gave us at the beginning of the problem tells me Well, pi is less than u is less than 3 pi over 2. Okay, whenever I see pi, I think radians, so it's a measure around the circle. All the way around is 2 pi, halfway around is pi. And 3 pi over 2, that's 1.5. So 1 pi, 1.5 pi. 1 pi, 1.5 pi. U is somewhere here. If u is somewhere here, that means if not only is sine squared negative, but cosine is negative as well. Neither squared is negative, but sine is negative, it's given, and cosine is negative. So we solved it to 4/5, but we know from what they're giving us that it's actually negative 4/5. And it would still work in the equation. Negative 4/5 squared is 16/25. So, when we solved it, really, I should have written plus or minus 4/5, because plus or minus 4/5 equals 16 squared equals 16/25. Okay, we do the same thing with cosine v is 12/13. So we plug that into the same equation. 12 cosine squared plus sine squared, doesn't matter what order it's in. Square 12/13, you get 144 over 169. How many 169ths is this? 169 169ths. 169 minus 144 is 25 169ths. These cancel, and we get b squared equals 25 169ths. So b is plus or minus 5/13, plus or minus. So we need a clue to see which quadrant it is. Well, they're telling us 0 is less than v is less than pi over 2. 0 is less than v is less than pi over 2. It's in the first quadrant. V is in the first quadrant. So sine and cosine are positive there, so sine v is 5/13. Now we have this information, we can plug it into this formula, because they're asking us for u minus v. So negative 3/5. So we're plugging in right here. I didn't even write this. We don't know what u and v are, but we can figure out what u minus v is anyway with all the information we've gathered. We multiply, we get negative 36/65. We multiply, we get negative 20/65. We're minusing a negative, so that's really addition. Negative 36 plus 20 is negative 16, and our answer is negative 16/65. So that's kind of it's similar to the problems we did on the last video, but we have that extra thinking we have to do about, well, what quadrant is this in? We had to use the Pythagorean identity to solve that. Okay, the next problem I'm going to do is solving an equation with